This is part 2 of our exploration of the unit circle, and we're going to learn in this video how we can utilize the unit circle to help us evaluate trigonometric ratios. So this is what your unit circle should look like. It should be all filled in, all of our special angles all the way around. Remember, our special angles are all multiples of 30 or 45, and we use a 30 60 90 triangle and a 45 45 90 triangle, those ratios, to get all of these coordinates. We saw that in the previous video. So keep your unit circle handy, and let's think about how we can utilize these special angles on the unit circle to get trigonometric ratios. Remember, trigonometric ratios, trigonometric evaluations are constant values that we use to solve mathematical problems. So first thing I've got is our pink rotation here, and let's think about this. If we're using our unit circle, this is 30, this is 45, this is 60. So we have pi over 3, or 60-degree rotation, and if we drop the altitude down, we create a 30, 60, 90 triangle. Remember, this is how we're getting these coordinates. Also remember that this is a unit circle, and if it is a unit circle, then we're talking about a radius of 1. So our hypotenuse here is 1. If our hypotenuse is 1, our short side is half of that, which is 1/2, and our long leg is simply 1/2 times the square root of 3, so root 3 over 2. So that translates, of course, to the coordinates over 1/2 up root 3 over 2. So let's focus just on this particular triangle here. And also keep in mind that this 60 degrees, this is our angle in question that we're dealing with. So if this is our triangle, and I'm going to just totally darken it in here because I want you focused just on this triangle. This is our angle in question. What would be the sine evaluation? The sine evaluation would be the opposite side over the hypotenuse. Well, if the hypotenuse is 1, then can't we just say that on the unit circle, the sine evaluation, the sine of 60 is simply the opposite side, which is root 3 over 2. And in terms of our coordinates, the sine evaluation is going to be the same thing as the y coordinate. We can see that they're the same right there. Conversely, what would our cosine be? So let's think about the cosine here, the cosine of 60 degrees. So here's our 60-degree angle. Cosine is adjacent over hypotenuse. So if our hypotenuse is 1, the cosine is just the adjacent side, which is 1/2. Or in this case, it is the same thing as the x coordinate. There it is right there. So we're going to see that happen over and over and over again. So let's move all the way around here to quadrant 3. Let's take a look at the rotation that I have marked here. So I am going to show you that, remember, anytime that we're drawing a rotation on the unit circle, we always start on this positive side of the x-axis, and we're going to rotate all the way around here. But in order to refer to a right triangle, we've got to drop an altitude here. Remember, the altitudes are always drawn relative to the x-axis. So think about where we are. So let's count and see where we are. 30, 45, 60, 90, 120, 135, 150, 180, 210, 225. So if we were to rotate all the way around into quadrant 3, we would be at a 225-degree rotation. But we're only going to consider the reference angle. And remember, this is the reference angle. A reference angle is always positive, always acute, and always formed with the x-axis because we draw our altitudes always vertically, always up or down to the x-axis. So if we went 45 degrees past that negative side of the x-axis, we're talking about a reference angle of 45, which means its other angle on the other side is 45. So a 45, 45, 90. Remember, a 45, 45, 90 is isosceles, which means these two sides are congruent. Now, if our radius of our unit circle is equal to 1, that makes both of our side values root 2 over root 2, root 2 over root 2. But we're in quadrant 3, which means we're going back and down, which puts our coordinate right down there at negative root 2 over 2 and positive root 2 over 2. So what is our sine value? So we just saw on the first triangle that the sine value is equal to the y coordinate. It's still true right down here because if this is our angle in question, what's opposite over hypotenuse? Opposite over hypotenuse, and I forgot my negative right there. Opposite over hypotenuse is negative root 2 over 2. So the sine of, and remember what did we say when we're going all the way around? That was a 225 degree rotation. The sine of 225 lands us in quadrant 3. So the sine value is the same as the y coordinate. It's negative root 2 over 2. The cosine is the x-coordinate. We saw that on the first triangle. We can also see it again here. The cosine is adjacent over hypotenuse. So the cosine of 225 is also negative root 2 over 2. Now, we didn't talk about the tangent up here. I'll hit it right here. The tangent is, of course, it is opposite over adjacent. And when your triangle is isosceles, your opposite and your adjacent sides, they are the same. Your x-coordinate and your y-coordinate, they are the same. So if we were to say opposite over adjacent, that would be negative root 2 over 2 over negative root 2 over 2. That would be equal to 1. Our tangent value in quadrant 3 is positive because both the x and the y coordinates are negative. We have everything positive in quadrant 1 and only the tangent positive in quadrant 3 because both the x and the y are negative. So if the sine is the y coordinate, then the sine function must be positive in quadrant 2 because all of these y coordinates will be positive while all of the x coordinates would be negative, meaning the sine would be positive in quadrant 2. So everything's positive in quadrant 1. The sine is positive in quadrant 2. The tangent is positive in quadrant 3. And if all of the x coordinates are positive in quadrant 4 and the y's are negative, that must mean that whatever has the same evaluation as the x coordinate, which in this case would be the cosine, that the cosine will be positive in quadrant number 4. We'll hit that again one more time on our last page of notes, but let's focus right now on this angle that I have drawn in green. Now this time, let's just think of it in terms of a negative rotation. So if I rotate negatively, and you can see here that I am down 30, if I'm down 30, I can draw in that right triangle right here and have a 30, 60, 90. My reference angle would be positive 30 because my reference angle is always positive, always acute, and always formed with the x-axis. So if I have a negative 30-degree rotation, I raise my altitude up to the x-axis, it creates a 30, 60, 90 triangle, which would have the coordinates, if my hypotenuse is 1, of positive root 3 over 2 and down 1/2. We can see that happening. Over root 3 over 2, down negative half. Once again, should be all neatly written on your unit circle that you should be very, very familiar with. So from here, and because my work is getting so messy, let's go and utilize an index card here. So if I have the sine of a negative 30-degree rotation, down 30, it's creating this triangle. My sine evaluation is going to be the y-coordinate, which is negative 1/2. My cosine of negative 30 is going to be my x-coordinate, which is positive root 3 over 2. My tangent of negative 30 is going to be opposite over adjacent, so that's negative 1/2 divided by root 3 over 2. Negative 1/2 divided by root 3 over 2. And of course, when we divide by a fraction, that turns into multiplication by the reciprocal. So negative 1/2 times 2 over root 3, cancel the 2's, we end up with a negative 1 over root 3, which we would then rationalize, and I didn't quite leave enough room, so I'm going to write it right off to the side here. So my final tangent of negative 30 would be negative root 3 over 3. So let's sum everything up on my next page of technologically advanced notes. So here we go. When using the unit circle, and yes, I'm like super ridiculously highlighting the fact that this only applies to the unit circle. The cosine value is the same as the x coordinate. The sine value is the same as the y coordinate. And the tangent value can be found by dividing the y coordinate over the x coordinate. So cosine is the same as the x, the sine is the same as the y, the tangent is y over x. Where? Only on the unit circle. Now, if you're in doubt, then you should draw a triangle. Let's get one other thing all reconciled here. When we're in the coordinate plane, what trigonometric values are positive in quadrant 1? All of them. All triggies are positive. In quadrant 2, only the sine and its reciprocal cosecant are positive. Everything else is negative. In quadrant 3 is the tangent and the cotangent. They are positive. Everything else is negative. In quadrant 4, we have the cosine and its reciprocal, the secant. They are positive in quadrant 4. Everything else is negative. And last thing, and I've said this a few times, let's write it in as some notes right over here. When it comes to reference angles are always positive. They are always acute. And they are always formed with the x-axis, because we only draw altitudes up to the x-axis or down to the x-axis. So these are the always statements to remember about reference angles. Always positive, always acute, always formed with the x-axis. That is how we utilize the unit circle.